In this video, we're going to cover how to solve linear equations and inequalities. For those who don't know me, my name is Chris Heinazoni. I used to work as an engineer for a defense company, and I've since left that to start a career in tutoring. I make these videos to help VC students do the best they can in math methods. With that out of the way, let's get into it. A linear equation is a particular type of equation. It's one where the highest power in that equation is 1. For example, y equals mx plus c would be considered linear, whereas an equation like y equals ax squared plus bx plus c would be considered nonlinear. It's that power of 2 or above that makes the equation nonlinear. Linear equations can look more complicated, like this one here, but it's still linear. The reason why is because the highest power in that equation is still just 1. Now, with that in mind, let's see how to actually solve linear equations. All linear equations are solved by rearranging until you get the variable of interest on its own, which in the vast majority of cases is just solving for x. We're going to start with a simpler example to begin with, and then work our way up. Rearranging equations requires an understanding of algebra. The main thing you need to watch out for here is that whenever you apply any operation, you have to do it to both sides of the equation. This is an area where people get wrong a lot. So for example, if I wanted to rearrange this equation here, I would not just be moving the 2 to the other side and making it a division. What I'm actually doing is dividing both sides of the equation by 2. This matters because when you have a more complicated linear equation, like this one here, where you have both a coefficient and a constant in there, dividing by 2 doesn't just mean you take the 2 from the coefficient and put it to the other side. No, it means dividing the entire left-hand side and the entire right-hand side by that coefficient of 2. And that looks like this. Now, once you've done that, you can continue to simplify this equation by subtracting 2 from both sides. That'll move the 2 from the left-hand side to the right-hand side. As a reminder, when it comes to adding or subtracting whole numbers from fractions, we need to make sure that that whole number is rewritten as a fraction with the same denominator, which in this case means multiplying and dividing the top and bottom by 2. So, if you struggle with algebra, think instead of just moving terms around, think about what's actually happening. You're applying an operation to both sides of an equation, which means you can't just pick and choose what terms you want to use, you have to use everything. Here's a more complicated example. One thing I'd recommend to start with is to cancel out any fractions as soon as possible, which we can do in this case by multiplying both sides of our equation by 2, since the denominator of the first fraction is 2. Once you expand through that multiplication, you'll see that the fraction disappears. We can actually do the exact same thing to the second fraction by multiplying both sides by 3. Once again, when you expand that out, you'll see that all the fractions now have disappeared. All we're going to do here is collect the like terms and simplify. So 3x and negative 4x are going to make negative x, and negative 9 and 8 are going to make negative 1. Now we've got to get the x on its own. And to do that, we can add 1 to both sides of the equation, since that'll cancel out the negative 1 on the left-hand side. And we're going to wrap it up by multiplying both sides by negative 1 to cancel out the negative on the left-hand side. Sometimes your linear equations are going to have more than one variable in them. But nothing major has changed here. We're still just going to be rearranging for x. The only difficult part about this is that the terms are no longer going to simplify together nicely. You're going to have a lot more things to keep track of. Once again, we're going to consider how to get x on its own. And in this case, we can achieve that by subtracting b from both sides. And finally, we're just going to divide both sides by a to get the x on its own. That's where we leave the answer. We've got x on one side and everything else on the other. The CAS actually has an inbuilt function to help you with this. So let's suppose you're in a tech active exam and you get a linear equation that looks really nasty like this one here. All you're going to do is wrap that up in a solve using the following syntax. The shortcut on the TI Inspire is to go to Menu, Algebra, and then Solve, whereas in the Casio it's highlighted here. Linear inequalities are more or less the same thing as linear equations. There's only one additional thing you need to be aware of, and that's that anytime you multiply or divide by a negative number, the direction of the inequality flips. We still want to get x on its own, and we can start to achieve that if we subtract 3 from both sides. This is not a multiplication or division by a negative number, so nothing else changes. We treat it just like we would for an equation. However, when we get to this stage, we realize we have to divide by negative 4. Because this is a division of a negative number, the direction of the inequality now needs to flip. You can solve these on the CAS as well, using pretty much the identical syntax. The only thing I'll touch on here is where to actually find those inequality symbols. On the TI Inspire, all you're going to do is hit Control and the equal sign, and you'll see a window pop up for all the inequalities. And for the Casio, it's located under the Math 3 section here. If you found this video helpful, then you should consider joining my free community. I host a Q&A call every week to personally help you through any of your specific questions, and you'll also get access to more resources like this, including written and recorded lecture content, as well as practice exams and SACs with detailed solutions. It's pretty cool. You should check it out. I'll see you there.